Where were we last time? Yes, we had a look at CSV. We had a look at working by CSV, how we basically utilize CSV with Python, and CSV is our normal buffered data sets where we use a kind of fast optimized method to crunch the data, to process the data, specifically for wherever we need really high throughput and high high cleaning, high processing for a particular subset of data, and that's why we use CSV. So CSV is really important, what you can say, a quite crucial element in Python data science solution generation, because we use it quite often. We use CSV reader, and we use the other supporting methods for CSV depending upon what we need to do in terms of the enumeration, iterations, and all those things. Also, have you tried on CSV hands-on? Means, have you worked on a couple of examples in CSV?
Yes, I did.
Okay, great. Because this is a need. There are quite a few questions asked on CSV, and as we know, what we do is we do research, right? So for research, whatever you do, you normally do it on your local, server or local machine. And for that, CSV is one of the best data throughput mechanism to change, align, augment the data as per the need of the solution. So this is the kind of first few steps we do as a data scientist, right? And last time we also started on basically learning about these libraries. We started on Pandas. So let me revise these things. Pandas is basically wide range of use wide range of fields, including academic, commercial domains. So we use Pandas in various domains. Panda is specifically used for data crunching, data preparations, data alignment, data cleaning, and we do this data processing like load, prepare, manipulate, model, and analyze data. The analysis part of it is quite far and few, but overall, to grab the data, if you're working via network, if you're working via internet, we normally use this Python, because Python Pandas. So Pandas library are really tuned up for a specific data throughput mechanism, so that you can pre-cook your data, you can get your data ready for actual processing. Okay, we do process model data to Python Panda quite a few times. So Panda is one of the most used library across Python data science solutioning. So we need to understand Python in depth. We need to practice Python, Pandas in depth, and we need to understand how Pandas helps us in building these, data scientist solutions. The first and foremost is basically the data frame object, which we used quite extensively in terms of building solutioning around data science, right? And then we load the data into memory. We retrieve the object from quite a few file formats. The data element integrated handling of missing data, reshaping and pivoting the data sets, creating some subset, dividing, slicing, and all those things we can do with Pandas. There are methods available. We can also do sorting data by aggregations and transformations. Again, this is specifically tuned for high performance data data throughputs. These Pandas library are also tuned up for particular hardwares as well, but they are using extensive, very precise business cases rather than generally. But normally, Panda is the best efficient mechanism next to CVS, next to the CVS file crunching, where we try to use efficient Pandas methods and derivations as from the libraries to crunch the data for our given work at hand. Okay, and yes, Pandas also includes some of the really great functionalities, time series functionality, time series compatibility, and all those things. Okay. I believe we all have Anaconda, so we don't have to worry about the PEEP and all. If you're not using Anaconda, then Anaconda or what's the other one? The basic single line editor in Anaconda, we are all covered in terms of updating the Pandas for us. Okay. If not, then you might need to download or use the pip to get the Panda updated if you're using some other environment. There are a few environments who go ahead, ma'am.
I have a question. Yeah, about the time series. What is a time series? I think not here, the previous slide. Time series functionality. What is that?
Okay, time series, as we talked about, basically it deals with the timestamp conversion. Okay, as we discussed last time, timestamp, if you heard,
Oh,
normally
times. Okay,
timestamp
okay.
conversion.
Timestamp in the database. Yeah, whenever we touch the row or something, it puts the timestamp there.
Yes, so normally we use functionality called ease update, right? And ease update is normally referred to the timestamp. How it's referred to timestamp, let me take a minute and explain to you. When you have your huge database, might be a big data where you're trying to understand, let's take the example of that Netflix thing. You're trying to release a new sitcom for a given region, and for that you need to analyze the data of the consumer behavior, like which type of consumers are looking for which type of web series, OTP series, and blah blah blah. So how do you analyze that thing in the recent time period, in the recent days or months? What are they searching for? Which type of sitcoms they are searching for? Are they romantic, action-oriented comedies, stand-up comedy, sitcom comedy, family comedy, adult comedy, and so on and so forth? So you normally apply these queries via your programming, and you normally sort this thing to a timestamp. Now, whenever you look at this data, well, if you look at some typical data across a region, the timestamp mostly 90%, 95%, they are uniform. But if you are using some different database, like in big data, we might upgrade quite a few, or migrate quite a few other database as well, right? So we normally carry forward their timestamp there. To handle these things, we have a good number of functionality to adjust this timestamp via Pandas. You can start index accordingly, even if you have different timestamp. Only you need to understand what type of different timestamps are already encoded, or how to analyze that. And there are some, even AI-based program to understand the timestamp correctly. So if you are using Asian timestamp, we have year, months, then days, like YYYY, 4Y, 2M, 2 days, then 2 hours, 2 minutes, 2 seconds, 2 nanoseconds, or 2 microseconds, depending upon which database you use, and how the timers is clocked on that given database server. And these type of things have a kind of dependency on them, right? On these data entities. Other if you can't get them aligned with your purpose or aligned with your solution, you are missing a crucial part of the data element, right? So that's why we need these things. They've added this thing in, I believe, late 2010 or 2005. Means pandas have really been building up on their evolution path, and they have built this time series conversions, indexing, and these functionality quite effectively now, and it's one of the most crucial one. Normally, I haven't seen anyone asking questions on time series, but at least as a solution, we need to know these things. Does that make sense, ma'am?
Yes, yes. Thank you. I understood.
Nobody asking questions, but there are some crucial things, right? So if you are targeting anything like consumer behavior, analyzing any data for a particular region, particular purpose, then time, the data entered is a
I
crucial.
think for the ad industry, it will be very helpful.
Come again, ma'am. Could you please repeat what you said?
Okay.
Could you please repeat your last statement, ma'am?
No, I was thinking like, the online shopping and all that. So all the people they target the customers. So for that, what this person was buying when. So all those kinds of functionality time series can help with, I guess. That's what I was.
Yes. Let me tell you a simple example of Amazon or Flipkart. Amazon uses Microsoft extensively. So they have,
No.
Sorry. No,
I was thinking it's some. Okay.
No, go ahead, please. Go ahead.
I think voice is breaking. So is it me or you? I don't know.
I can hear you clearly. Okay, let me explain. in Amazon, if you're trying to have online consumer behavior or online consumer trend, they normally use Amazon is a kind of Microsoft house, so they use MS SQL. They use MS SQL latest servers. So the timestamp is clamped with the MS SQL way of working. MS SQL goes in North America as Y, 4Y, 2Ms, 2Ds. Then we have hours, minutes, seconds, and microseconds. This is a standard format, unless you change. Normally, whenever a data entry has, like Ravindra Pandey have purchased what I purchased last time. Okay, I purchased a hair trimmer, that hair trimmer. So that hair trimmer, what company, what he browsed through, like I like Philips, frankly speaking, and Philips has good amount of variety as far as trimmer goes. So you need to understand how these different type of models, Philips, and there are quite a few others which are famous in particular region, particular countries, because of their manufacturing cost, because of their distribution cost, and all those things. So if you go for a particular kind of brand with a particular kind of subset of a brand, means a model for that matters, and you try to understand the search pattern for a given consumers, the online consumers, or the purchase pattern of online consumers. For that, you need to index the data as per the latest at first, and whatever data span you're trying to analyze for a month, for a week, the last day of the week or last month day of the month will come at the bottom, and that's how you normally index the data, and then try to understand the weightage of the respective behavioral pattern. Specifically in behavioral pattern, in terms of consumers, regional distributions, in terms of the supply chain consumptions overall, you normally use time series extensively because it's a time sensitive data. Just to sum up in a statement, time series data or the time sensitive data is a real crucial part of our research, right? Most of the time, and
Yeah.
everywhere we normally use pandas to basically get these functions effectively managed, effectively handled for the throughput. Does that make sense, ma'am?
Yes, yes, I understood. Thank you.
I believe because nowadays consumer, pattern study is most important and asked quite a few times in an interview. There could be a question on time series, like who is the, which is the best library we can use as far as consumer, time series functionality goes. So yes, there could be some question on time series functionality also. Let me try to search some videos if I have, and I'll share those with you after a session also. Okay?
That'd be good. Thank you.
Most welcome, most welcome. Now, yeah, so we know how to get Panda. Then yes, we have seen these three different, data types which we use extensively with Pandas. Data frames are the most used as a data scientist. Okay, and yes, series is just one row or a kind of singular matrix. Data frame is kind of a two-level matrix, like a table, or a kind of X by X type of matrix filled of data. Then we have panel, where we have a logical array of 3D data. So we have a table with number of z-axis rows as well, or z-axis slices as well, as they normally refer to. Okay, we mostly use frames. So let's not complicate matter. We hardly use panel because panels are really confusing in terms of solution deduction, in terms of understanding how or the indexing takes a hell lot of time. I think if you really want to compare the data frames and panels, the panels throughput almost 6 to 8 times difficult than data frames. So that's why data frame is the I think is the heaviest complexity we normally go as far as solution goes. But if you're working on some really scientific data or a kind of techie solution, you might use panel as well, but they are far and few. Okay, mutability in terms of yeah, we seen data frame is I have given the slide name not correct, I believe. Okay, all panda data structure are value mutable, can be changed except the series. They are size mutable, so you can't change the series in terms of their size structure. Okay, once you created, you normally use it for read method. Data frame is widely used, and one of the most important data structure, as I just said, panel is used is far and few. Okay, series is one dimensional, as is shown in this example. We had to look at these things. Then we had to look at these data frames. Data frames is a two-dimensional array. So we have column and rows, or we can say X and Y, right? Table represents data cells, team of the organization with their overall performance rating, right? The data is represented in rows and column. Each column represents attributes as normally in the database. Each row represents a person or a record. So horizontal record, vertical attribute, column or category. Okay, we need to remember that. I believe we try to, pardon me, we try to execute this example where we try to build a data set with the cars and passing, and we try to basically print it on the output terminal as well. Okay, in panel, it's a three-dimensional data. So we have X, we have Y, and we have Z axis as well, or Z axis as well, as the North American normally pronounce. It is hard to represent the panel in a graphical representation, but a panel can be illustrated as a container of a data frame. So there are quite a few data frame or a container with many sheets, right? So a data frame, each data frame can be a sheet piled on one top of another. Okay, we had to look at how Panda basically helps us out in building the data solution last time. Okay, let's take a step further. Now, how to create an empty series. To create an empty series, I'm trying to create a series with data type float 64. It's as simple as that. We are just creating a row of data, as simple as that. And here the data type is float. Normally the syntax is we have a series, curly braces, and I'm trying to basically create a series of float with a I think dictionary, right? What are these square braces?
Lists.
So data type is float. So I'm trying to create a dictionary of float with one series. So it will just have one row. Okay, I can add another row to that. Okay, data frame, we tried these things, and yes, there are versions. We normally refer to in terms of Panda versions, and if you want to check out Panda version, you can use the statement called pd panda underscore version underscore that thing. Okay, let me try to run this for you so that even I'll know if it's got updated or not. That's the last time I took the screenshot. So so let me, okay, and I'll go.
I have a question.
Yes, ma'am. Please go ahead.
While if we have to do data science, we'll have to handle with lot of data, right? So
That's right.
what if we have to handle like very big data, not a micro MS SQL cannot handle, like I've heard something like in terabytes or something like that. What do we do at that time? Do we need to know more about the big data kind of stuff, or
We'll have a session on big data. Don't worry on that part.
oh, okay.
We'll have a session on how to migrate from, let's say, Oracle or MS SQL to big data, or MySQL to big data. And we'll
Okay.
have those things. Don't worry on that part. But you are right. We normally move to big data. Okay. And wherever you go, you normally will have this database given to you, be it a big data, MySQL, MS SQL, whatnot. So we need to just understand how we can, utilize these methods available with libraries rather than having data communication things, because data communication block or method we just built once and they are handled in that scenario, and normally those objects are given to you.
Okay.
Because we normally extend from somebody, right? Means whenever we start programming, so there they will have some abstract layer for data communication, or they will have some abstract thought process of how they churn out that big data. But big data is normally buffered and then churned out, because every time if you depend on your network, and if the big data is used by let's say 300 or the consumers, 300 or either programmer or if the data churning is really high, then the availability of data can be a challenge. So what they normally do, They normally give you some specific time to basically churn out data. As an new data scientist, I'm trying to tell you. So what you do, you normally get the data in a CVS file, whatever you need. You put down those queries. You give it to these database DB team. That's what they normally call, and they'll get a CVS file to you. It can be some TBD CVS file. It will come to you in a day or two, as per the processing speed, and then you normally churn that CVS file. That's what I'm saying. CVS churning is most important thing we do as a data scientist. We play on CVS on my local system, because nowadays these SD drives or M2 drives are really fast enough. They normally work at a speed of a normal random access memory. If you know what I'm talking about.
Yes, yes, I
Yeah,
understand.
so it's
Yeah.
normally a couple of GB per second type of throughputs we are looking at. And these M2 drives, they can easily scale up to a couple of TBs at your local system. So what they do, they dump couple of GBs on your drive, that M2 drive or SSD drive, and you start churning those things, those CSV files via your programming, to make sure you clean the data, you align the data. So whatever processing you do on the data is from that local system. So you don't need that much security in this data communication. It also basically we also go away from all those extra what you can say wait cycle for networks and everything. So that's how this is a normal common practice in typical Python data science working as of date, and that's how we are moving to. But whenever you're right, whenever we are doing actual project, like if you're releasing it to production, or if you're releasing it for integration testing and all, that time, yes, that time we use big data, and that time we just extend the abstract layer to have these data buffered layer included in that. So rather than using local CSV, then you normally direct your queries to the big data, and that we'll have a look at. We'll have a look at that big data queries also. Okay, no problem there.
Okay. Okay.
Okay, now I'm just running this thing. I have commented it around time. Panda version is 1.3.4 in my Spider basically. I'll just check if I can update or check for the update. Copy version info legal. No, I don't know how to update this thing. Could you update this from here? Yeah, check for update. So if you click here, it's checking for update. Wait a minute, but it's not showing any progress or something. It's not animal, I believe. Okay, Spider is updated. So this is the latest version I have with me. So I have 1.3.4. That's the Panda version I'm looking at. Okay, sure. Let's go back to my presentation thing. Yeah. So this is what the data frame is, the most used object. Let's try to throw away a good light on NumPy, and this is a numerical Python. So wherever you want to do numerical calculations, numerical and also indexing comes under numerical calculation, because what you do in indexing, you normally try to fit in the greater than or less than clauses, right? And you execute it as a query. So if A is greater than B, you'll have the row moved up or moved down, and this is what it happens in indexing normally at a ground level. So in indexing we use NumPy. In number crunching, if there are any mathematical formulas, mathematical functions like Laplace functions, and various other functions, we normally use NumPy. NumPy is basically numerical Python. NumPy stands for numerical Python. It's a library consisting of multi-dimensional array objects. So instead of using panels in pandas, we use NumPys. Okay, let's try to understand how when we normally go with NumPy. Using NumPy, mathematical and logical operations on array can be performed. Okay, we know mathematical and logical operations, right? So I'll not repeat those things. NumPy is a Python package. It stands for numerical Python. It is a library consist of multi-dimensional array objects and collections for routines for processing of an array. Numeric, the ancestor of NumPy, he was developed by Jim. Another package, NumArray, was also developed. Having some additional functionalities in 2005, Travis created NumPy, or he's basically integrated this couple of packages or couple of libraries together and created a new package called NumPy. By incorporating the feature of num array into numeric package, there are many contributions to this open source project as well. Okay, if you go to WC School and search for NumPy intro, you will get all those details. Okay, I'll share this link with you. Don't worry. Operation using NumPy. Let's try to understand how and where we use NumPy. Using NumPy, a developer can perform these operations: mathematical and logical, Fourier transform, routines, shape manipulations, operation related to linear algebra. Okay. NumPy has built-in function for linear algebra and random number generation as well. And we'll have a look at these in detail in a couple of slides. NumPy, a replacement of Matlab. Have any of you worked on Matlab? No, no problem. Matlab or Matplotlib is a basically mathematical library which was available, or which are basically extended for Fortran. Fortran is basically a language used by engineers, prior to, I believe, 2000 or 2K. We use Matplotlib with Fortran, frankly speaking, in our engineering days, where we used to crunch data at much faster rate than we used to do it with even MS SQL, Oracle, in those type of or DB2, those kind of databases. So Matplotlib was the first effort specifically made towards having the maximum utilization of a math coprocessor available on your computer, and that's how the overall evolution of having math coprocessor started. This was in early 1994, 95, 96, where we normally came up with a processor called 186, about 8080. 8080 was a basic processor, or Z80 was a basic processor, where we actually started on building mathematical processors specifically for crunching, specifically for mathematical operations. And then we also go on in the direction of creating more graphical processor also, which got filled in a couple of years. So as the Intel are normally aligned to, they are aligned to better mathematical operations. So we put in lots of efforts to improve our mathematical crunching with these CPUs and math processor. That's what we used to refer at that time. We come up with 186. Now 186, other than 8080, 186 is basically 80186 or the processor name. This was Intel processor, and there it normally came with 8080 was just 8-bit data with one row. 186 have 8-bit data with 8-bit matrix. So you can address 8 by 8, that's 64 data path instantly with one CPU cycle, as far as 80186 goes. Now this is important to understand, because here what we are trying to do, we are giving a separate another MUP to manage this because now we are trying to address multiple instructions, trying to execute multiple instructions at a single given instances. This was very early days of multi-threading. From 386, we actually started with multi-threading. Why this is important? Because as a data solution, when I go to a level of data crunch at a cycle, I need to understand this processor evolution also. Nowadays, we have octa-core with 64 by 64 matrix addressed with a single cycle. If you look at the latest i5, i7, and if you go to Intel, or if you go to, even if you have AMDs, you can go to the respective size and try to understand how much data path or data bit they got. Okay, so we have octa, means 8 core, 8 processor, each with 64 by 64 data path to be addressed. And so we can address so much RAM, because the random access memory does gets loaded into the IQ as an starting address, ending address, checksums, and everything. I don't want to really disturb you with this technicality. Just to get the crux of the matter, the math processor evolution started around 1994, and then it migrated to a level where we have a processor dedicated or a couple of processor dedicated for math crunching in our today's multi-processor based desktop laptops what we use on day-to-day basis. So math crunching is normally much easier, much efficient nowadays. And so for those infrastructure, we have all these libraries tuned with those infrastructure. Does that make sense, or am I talking too technical? Pardon me for that. Have you understand?
We are good.
Yes.
We are good.
Do you understand? Nobody will ask you this, but in case if you're discussing with some colleagues, data scientists, if you tell them these evolutions, date timelines, they'll really respect you, because this is the history how the mathematical processing got into multiple executions or multi-threaded executions, and with the efficient time. That's why we can basically do something like obstruction analysis. We can do something like the laser array obstruction matrix addressed within milliseconds, and then we can build the response time of that driverless car up to a level, not up to a level of human, but up to a level of kids with the age of 1 or 2 years. Still we need to reach to a level, but in near future I believe we are getting nearer and nearer day by day. The data crunching have I think we have optimized up to a great extent. Now we are trying for the storage and the response time of storages. So right now we have something called Intel Optane memory, which can go to a throughput of 26 GB per second. So that's what we reached in terms of crunching. Now we are having a look at this data throughput is a challenge. We can have multiple processors working at our disposal. With either you can have additional MUP cards or co-processors cards, and you can just include even in your desktop. Forget about those big servers which you have at your disposal and which are really cheap nowadays. In my good old days, where when I used to work, this was in 2004, 2006. Whenever we used to procure a server, it used to go into millions of dollars, and the server configuration was really stringent. Means we are talking of something like 48 processors with let's say 2 petabytes of storage, some 20 gig of RAM or something like that, with a throughput of around 2 gig per second or something like that. So, but still nowadays 2 gig is what I can have on my desktop. I have a M2 drive of 512 GB, and I have a i5 with the latest possible fast processor, and that's how I'm using an Intel board right now. So I can get a throughput, at least memory throughput is at around 18.5 gig per second. Believe me, my M2 drive gives around 18.5 gig per second. And if I use the overall, this is with Intel Optane. Even I have that M2 drive from I don't remember the company, but yes, the throughput is really good. Means I can have a full K video plotted to my screen. I'm using TV as my screen. I have a 43-inch TV attached to my desktop, where I can see really big 4K resolutions, where I can have these 4K movies played at a speed of 28 frames per second. And if you understand what is 4K, 4K is what we are talking about: true colors up to 16.7 million colors per palette, with the resolution addressable of 3000 with something pixel by 4000 something pixels. So we are having 4K by 3K pixel address intensity with 16.7 million color palettes per pixel. So that's the viewports I'm addressing with my desktop. Believe me, these movie experiences are out of the world. Means when we started actually using movies on our desktop with the I've built my first computer in 1993 with a Z80 processor, Intel 8080, with 64 KB of RAM, and I think 1 gig of hard drive, which used to sound like I'm how aeroplanes take off. If you look at the A380s of the planes, the way they sound when they took off, my hard drive used to sound like that. It used to really starts it spinning, and even to reach its actual spinning capacity, I need to wait around for 20 or 25 seconds for that at that time. And the maximum capacity I was working at 1 gigabyte as an hard drive. Now I have 16 gig of memory on my desktop. Look at the way we are working. Look at the way the data throughput is working. So these NumPy library is highly tuned up with the latest infrastructure. And the pandas are tuned for your infrastructure. If you purchase a particular version of pandas, there are pandas available for supercomputers, for high-end or gaming desktop. That's what they call. For normal desktop, I'm using, it's almost on the verge of gaming, but it's not a gaming desktop. But still, I have these versions available to me. Okay, so do read the W3 page on pandas and NumPy, so you'll get an idea, right? I don't know why I have a video for NumPy. Give me a minute, I'll try to search for those things. A video for NumPy, right? Do you have? Yes. I have a quick video on NumPy versus Panda, so that we'll understand the difference in a scenario where we will try to yeah. So yes, I have example dot I'll show that thing to you. Let me open these things. Stop share, share screen, and share the file manager. Where's my file manager? No, not that. Yes, I have example. Could you see these things? It's a CSV file. Okay. And if I open this thing, this normally gets opened in Excel, because that's the association my Windows 10 have already did. And this is the kind of data which I have had as in CSV file: order date, region, blah blah blah. Think it as an typical what you can say sales data. So you have region, representative items, units, unit cost, total, bins, frequency, and so on and so forth.
Can't
Okay.
see the file.
Oh, sorry. Okay, I need to share that Excel. Pardon me for that. Where's that Excel thing? Yeah. Okay, sorry. Could you see my Excel here?
Yes, you can see it now.
Now, this is the data which I'm going to use as far as our typical CSV read write, with Panda goes. Okay. So we have dates as in first column. We have region, second column, representative name, the item he's selling, units, unit cost, total. Then I have various other type of data here, and trying to basically create a what you can say a typical solution via my data science capability or data science library. Let me open the spider for you. Yeah, this was the spider, and see, it's just a 3 line of data. I'm converting the df to string, and I'm getting it printed. Let me try to run it. See, now I got all the data converted to a single string or single data frame string. Could you see this huge data? I've converted the complete CS file. Okay, let me showcase you. And this is just 3 line of codes. One is import, or rather 1 line of code, I'll say. So I'm just reading and printing the CSV file. Could you see the it's not a huge, but it's a big file, right? Means you have how many rows and columns? Let me try to open that Excel again. Yes, it has around 1, 2, 3, 4, 5. So P is like some around 16, 18 columns, and rows are around 35 odd rows or more. No,
There's,
yeah.
there's something called describe, right? Data frame dot describe. It will tell all number of columns and everything.
Yeah, you can have. Yeah, you can print that. Yeah, you're right. Okay. Okay, that's good. Tell me, print df dot. Sorry, df dot. It is alt space, right?
Describe.
DESCRIBE. Describe text. Okay, let me. Yes, 47 rows, 16 columns. Oh wow, that's great. So and I can add even. Okay, so this is really great. Means the way.
We can't see the screen.
Oh, sorry. Where do I, no, let me go to Zoom, share screen, spider, yes. Yeah, I'll run, I have just added this 14th statement. Could you read? df.describe, and I'm this program. So this is the description of that data frame which I'm talking about. And this is the data frame it printed for me. Okay. Print out another row where line, so that I'll know I have basically it is. Okay, and I'll explain, or I can clear this, I believe, right? How can I clear this? Clear console, and I'll run again so that you know. Yes. So yeah, and now I don't know why I have aligned this data also. Previously, no, it's printing 2 times, I believe. Why it's printing twice? Found method ND frame describes. Okay, this is the description it talks about. This is the what you can say header, and then it starts with the next row as a 0. So it describes the complete data frame. Look at the way it's giving you the analysis. Even I'm using this thing for the first time. Believe me. So this was our last tip. Let me try to comment this thing. PDF to string. So using PDFs to string is not really a great way to showcase this, but this is the right way, I believe. More to understand. Let me do it this way. This will be much more. Start of the line. It's not line. It's like data frame, right? Okay. Let me try to run again. Come on. And I'll run again. Now see, I don't need to convert it to string. Simple. This DF describes give me a complete description of that data frame, which I dumped it with the complete Excel sheet. This CSV is basically an Excel sheet, or you can call it flat file DB. It's really good. Thanks a lot, madam. And this is what we need to play around and learn from these different methods. There are quite a few methods which might have got added, okay, which might get have improved in terms of various libraries. So there are various methods which I haven't used in past. So these type of possibilities are also there. Okay, so do some practice by your own, and yes, this is going to help you in a very long run. Okay, now here the null is represented as NaN. So that's also another thing. This is from, I think, CSV to data frame conversion. That's what it replaces the null value with NaN. Okay, so that's another thing to remember. Whenever we are going to clean data, we should be able to remove this NaN type of data. Okay, so this is a kind of single line program which we use with CVS read rather than having those a longer program which we used earlier with around 10-15 lines. Does that make sense to you?
Yeah.
Yes.
Okay, no problem. And yes, I try to this is a dictionary into data frame. Yeah, this was the program which I showcased to you. So you just dump the complete dictionary with strings and numerical those pairs, and you have that data frame dumped into the data frame basically, and then you can paste this thing in your CSV also. So you can write this thing to the CSV. As we know, we have done read write with CSV right earlier. So I don't want to waste your time on showing the same thing again. Please do try, take it as a homework. Okay, try to create a CSV from a data frame, or try to create a data frame from CSV and then write to another CSV. Okay, and now you know one additional method to describe data frame, which gives you all the details of length and breadth of the CSV as well. Try to use some Excel sheet, try to save it as a CSV. Okay, I'll tell you how to save the Excel sheet of a CSV. So let me open yes. Okay, oh, come on. Okay, this is a recording sheet which I have downloaded from Zoom recording and some YouTube published things and the description. Simple enough. Now I want to save these things as in CSV. How I'll do it? I'll go to the these things, and
Excuse
here.
me, sir. I think we are just seeing only your PPT actually.
Sorry.
Yeah. Now it has changed. Yeah.
Okay. Could you see the Excel thing?
Yeah. Now we are able to see. Yeah.
Pardon me for that. Okay. So this is the Excel file. It's a typical XLS, right? Means I'm using Office. Let me go to the version. Where the hell I can go to version? Nowadays, everywhere they've just changed the whole thing. Okay, where can I showcase you the version of my Excel? There's no help here. Is there any help here? Account. Yes, I'm using Office 2013. Okay, and if I go to Office, there could be some differences in menus. If I go to Office, if I go to save, there's no CSV. Yeah, there are CSV listed here. So there's a docs txt, there's a ms-dos CSV, and there's a Macintosh CSV. Okay, you can choose either one. They are similar. Only I think the header differs minor changes. I'll go with ms-dos CSV. Okay, so I'm trying to save this as a CSV, and I'll just change the name just to so that I can basically use it for my practice. Okay, so session links, and today is 28th March. I'm just 2022 syslings. Let me call it this thing. Simple enough. I'll save this as a CSV. Yes, it says some features are not available, blah, 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 blah. I'm closing my Excel. Yes. Okay. So I've closed my Excel, right? Now I came back to, I'll go back to my Spider with Spider. Okay. And I'll try to use my this CSV file. The name of the CSV file, let me go to my file manager and get that. Yes. Oh, come on. Sorry, give me a minute. Copy. Could you see my Spider? I'm just replacing the name, with the name of the file. Okay. And now I'll try to read that thing. Let me clear this thing for you. And I'll play it again. Could you see?
Yes, we can see.
So this is how it's coming. I think I couldn't see the YouTube links. Okay? There were some YouTube links. I'm missing on the links, I believe. So the conversion, let me try to open that, can I share the entire screen so that I don't have to really, share idea pad. Okay, entire screen. Let me try to use these things. And I'll go to, no, not share. I'll go to my file manager. If I go to my file manager, could you see my file manager now?
Yes, we can see.
Yeah.
It created a CSV read new. I don't know why. If I open these things, there were okay. But there are some links here, right? I don't know why it's not showing this column specifically. So there's a topic. there's a YouTube link and there are details like, so if I go to my here, I'm able to see the numbers. Okay, let me try to, rather than describe, let me try to print this to string and let me check out. Oh, come on, print. And let me check out if this is working better than this thing. There should be some, challenges there. Let me try to. Yes, now I can see the link. So whenever you convert it to describe, it's up your. Could you see the links here?
Yeah, you can see the
It's, yeah, it's also bringing up the special character. But if you do the same with this describe thing, it's not showing us the link. Let me try to showcase you again. So now the things are different. Could you see that?
Yeah, yeah.
It's showing me the description and the number of, and it's showing these dots instead of showing me the links and some special characters and all. So that's the difference between describe and actually convert it to a string and print. So when you convert it to string, you are getting the complete data. When you try to describe it, it just describes the overall what you can say, it's just ignoring the not I think text matters or so Unicode to strings, you are getting the actual Unicode of conversion from string to Excel. But whenever you say describe, you just convert the text for you. I hope you're understanding what I'm trying to say here.
Yeah, but
I'm also learning with you. Means I have never used describe earlier. That's why I can clearly show you. And this is what the overall learning at a scientist level means. So what I'm trying to do, I'm trying to play on with these different methods, functions, or various techniques available to me. So do play around with it, okay? And believe me, you are going to use CSV file, give and take, or read, write, update, modify. Whenever you start working, believe me, it's one of the most frequently used methodologies or techniques we used in our real job. Okay, so please have a look at these things. Please play around with CSV data frames and the conversion there too. Play around with it, and we'll basically try to describe or try to discuss this thing in our next session as well. This is really important for us. Okay, let me take back to you my presentation. Could you see my presentation?
Yeah.
Okay, great. Now this scaling screen really works a bit better. Now, I believe who asked me these things? Oh man, there was a participant for my last session. He asked me a question of how do I do data cleaning, and this is one of the most question asked in a data scientist interview. How do you do data cleaning? It's really important. We have discussed this thing a couple of times. I'm going to repeat that thing for our interview preparations or for our revision purpose as well. So let's have a look at it. Data cleaning means fixing the bad data in your data set. Whatever data set, whatever database given to you, to cook that data before you actually start using it. Believe me, because we are normally working with petabytes and zettabytes of data. So for wherever we start working, we need to clean this data. We need to take this data to a level where I'll start understanding what I actually need from this plethora of data given to me. Believe me, the data normally given to you is huge data, plus they have quite a few things which you don't need. There could be something like, empty cells. As we see now, CVS file, right? There are empty cells. Data in wrong format. Think about time series. Think about that, timestamp. Think about various, Unicode characters which are included, like special characters and all. So whenever you're going to crunch that data, it's going to create problems for you. Okay, wrong data, give me a minute and then we'll talk about wrong data, because wrong data itself is a huge term. And why, I'll tell you in some time. Duplicates, yes, duplicates. There are a good number of methods available in Pandas as well as Numpy to exclude duplicates, and we'll learn on that. Now let's come to wrong data. What is wrong data? There are basically 2 or 3 different type of wrong data. One wrong data is basically wrongly formatted, which we just discussed in data wrong format. Other wrong data can be the category or the attributes versus wrong data. So where there should be first name, there are addresses or there are date of birth. I have the data like age. This thing happens normally. Whenever you get the data from some party, in the column of date of birth, you might have age. In the column of sex, you might have a blanks. So blank also can be a wrong data. In the place of numerics, you might have alphanumeric contents. In the place of special, even in index column or key, we have some data which is misplaced. Might be due to conversion from platform to platform. In big data, we might work on various different operating systems as well. And whenever you normally tries to transition data from, let's say, a Unix to Linux, from a Unix to Windows, or Mac to Windows, or Mac to Linux, these OS tend to damage some of our data while transitioning. So whenever these damage do happen, now we have reduced these damages or OS transitional damages up to a great extent. But if you look at data scientist solutions, let's say 3 years down the line, or 3 years earlier or 4 years earlier, they used to spend huge amount of data on these, OS conversion or OS transition based data. You can say corruption. It's not a corruption because data is not corrupted. It's got misplaced most of the time due to the way, the tab. If you understand the tab on a keyboard, it measured or it represented in different Unicode character across OS. And this is the one of the most, I think, what you can say, or rather the worst thing you normally have as far as IT fraternity. You have these different OS can understand the keyboard character differently. And that's why we have many such challenges. The tab is a good example to discuss if interviewer asks you how the OS data transfer can damage the wrong data or can give you a lots of wrong data elements in your database. So you can explain specifically on tab, date time formats, or the time series format by itself. Okay, let me try to give you a good video on data cleaning. Okay, and we'll discuss data cleaning a bit more. Okay, so I'll go to Python machine learning. Okay. Okay, let me. Okay, could you see this video? Okay, let me. Okay. The foremost thing which we do in terms of data cleaning is first understand why we need basically to build a solution on the basis of data. Now, how the data is deviated. Deviated in the sense, if you're looking for something like consumer behavior, we need to understand how that behavior has been changed, evolved, or changing for new things. Now, new things in a consumer behavior patterns are basically noise. Means they should be treated as a noise because those are new, right? They are far and few. But still, sometimes they can trigger a change in the pattern altogether. Means we've seen there are quite a few good number of sitcoms who just got famous because of a new idea or new cultural thought process, new festival thought process or something like that. So in that scenario, there are these noise also take a crux or crucial part in a data scientist solution designing as well. So like you can't apply a similar data cleaning across the board. As we discuss the quartile and range of the values, here what we're trying to do, we are trying to basically get the data aligned as per the mean or median. But the most important part, sometimes the exception or noise can help a lot to these solutions or to understand some aspects of a solution which are crucial to the business decision. So you can't just apply a single thumb rule for data cleaning. Well, the methods could be one way or the similar, or you could present within the group of data scientists to make sure whatever you're thinking in terms of data cleaning is in alignment with everybody else thought as well. Or you can try it the other way than the others are thinking, and you might reach at some different results which might be more appealing to the business. These things do happen in data scientist world. So how do you think, how do you understand the data will drive the overall output for you? As we normally say, garbage in, garbage out, and so on and so forth. So there could be, if you have issue with thought process of building a data solutions, we might need to sit back and update our thought process in terms of how can I support the business in a best possible way as a data scientist. That will be our crucial thought process rather than just following the bandwagon. We are data scientists, we are not a programmer. And that's what differs for us. The out of the box thinking makes the solution much more appealing even to the business most of the time. It doesn't mean that you need to go the other way the other scientists are working, but more or less your thinking as an artist, your thinking as a scientist can give business solution which are out of the box or out of the ordinary. Could you understand what I'm trying to mention here?
Yes.
Sure.
I have a question, like in the data cleaning video, towards the end he said something about regularization. What does that mean?
Yes, great question. Actually, how to define noise, right, is another what you can say point to think through. Noise for me can be a music to my kid. Could you understand if you have kid from the age of 14 to 20 and their choice of musicals? Am I giving the right example here?
Yes.
I have experienced that, right? Means I have two daughters who are in 12 right now. They are at 17 years. They like those K-pops. They studied Korean and Japanese for that to understand the K-pop and all. I haven't, but I have learned a couple of numbers, a couple of musical video and the English conversion. The way they sing means one sentence is not really relevant with the next. And the extensive guitar and drum really make the sound more of a band rather than a singing. I know as an Indian, you can relate to my thought process, and that's why I'm sharing this thing. Now, to me, that's a noise. What I really want to understand is the meaning of music, the overall evolution of thought process in that song itself. Take a simple example of any Hindi song for that matter, any older Hindi song. Not that, you are samosa for me or something like that sort. That's a song. That's a Hindi song. Tu mera samosa is supposed to be, I don't know, I don't remember. Let's take a song like Tu Pyar Ka Sagar Hai. It was old movie, and I think Hemant Kumar sang this song for I forgot the name of the hero. It's a prayer. He's singing in front of a murti at an orphanage. But the song evolves in such a great impression of life progressions. To me, the singing matters most than the music. The rag, the lay, the rhythm matters much more to me than the overall music or the loudness of the music or the just thump of that music. To some, that can be the most important part, and the rest is just a noise. If you go to a club or something like, the thump matters the most, because that's why you are there to shake your leg or something like that sort. But in a normal scenario where I want to listen to a music, I normally drawn more towards, or my liking is more towards the meaning of song, the slow lay rhythm and progression of the song, progression of the thought process or the idea the poet have been embedded in the song. And this is how my thinking of noise. But for others, that thumb starts the crust. So for them, the overall simple, slow moving songs are noise. Like this way, for many businesses, in general, the noise is the deviation. And this goes up to, I think, 60 to 90% most of the time. But to some, as a scientist, we are there to solve exceptions. If you know what I'm trying to say here, as a scientist, as an evolved programmer, or as an evolved architect, or designers, we try to solve exceptions. So those exceptions are much more important in my thought process uh, than the overall regular data. So what is a noise is which is not regular. Regular is what is the quartile range, how that mean and median is adhering to the whole data sets, and so on. So for them, the deviation is a noise. But to quite a few good number of solution makers, deviation can be a really important part. We still need to remove the deviation up to the last dot in most of the scenarios, in quite a few number of cases, rather than most of the scenarios. So for them, the noise is the most crucial element in the data. Or I'll start basically looking at the exception first. Then I'll go and start understanding the actual mean, median, and the deviation of from the regularized data. So that's what the regularized data is all about. Whatever data along the mean, median is my regularized data, or is my data which is in a normalized format. So regularized data is the data is in a normalized format. I don't go for too much deviation or noise. Does that answer your question, ma'am?
Yes, yes, I understand now. Yeah.
And yeah, this is a really good question. This is a question which I would ask if I want to hire a scientist, because then I will understand his or her thought process, like how he or she is thinking. She or he can think in out of box as well as normal scenario, and he or she is looking at the data from a third party perspectives rather than the interested party in the data. This differs the thing up to a great level, because as a scientist, you have to look at that data from quite a few angles rather than just the user of the data. We are using the users are giving the normalized data, but the exceptions are also important. Does that relate to the solution? Am I trying to suppress the noise, or am I trying to understand how that noise is part of the data, why it's there, so that the next user or the solution behavior can be well tuned with the regularized user or a normal user. Okay, so there are a couple of ways to describe this. I'm just sharing my thought process the way I think. Okay, which does matter, because we need to learn step by step, right? You might have some different way of explaining it. Do you want to explain in your word what do you think about regular data or normalized data? Or whatever you understood.
Which falls within the sample, like most of the sample values, I mean, most of the values are in that norm area. That's why that's the place where you have many values. That's normalized data.
Mean and median, what we're talking
Mean
about.
and median, yeah.
That's right. So you got the point, no problem. You can think it through and spend some more time, right? Now we are okay. We are basically starting on to data frame, where we try to manipulate the data frame as per our needs and functions. Now we have, I think, understood what the data is doing to us, how to clean the data. Try to think it through. What do you mean by cleaning the data? Because cleaning to some is just, as we discussed, reducing the outliers or reducing the noise. To some, that noise can basically lead you to a solution. So that way, ponder on some, data cleaning. And in next session, we might discuss on data cleaning first, because data cleaning is one of the most important part data scientist does. Data cleaning, data pre-cooking, data alignment to the business solution is the most important part. Once you through with that, if you're confident in that process, then building data solutions are really a kind of matter of implementation. Does require brilliance? Yes, everything require brilliance, but it's a kind of, the sequence will, how do you say, the chips will fall. So data cleaning is the start of basically making data scientist solutions. That's why understanding data is the first, of course, and then you clean the data. So understanding is the most important part as far as the data goes, as far as the solution in need goes. So we start thinking the relevance of a business need to the data and their solutioning. If you can connect these three dots, you are on the right path. But if you are thinking too much on how to clean data or how to basically implement the solution, then it's more of a laborious thing you are thinking on rather than as a scientist. So this is what the scientists differ from the programmers. So we are more of a thought-provoking community than a typical let me get this thing done. It's not let's do it. It's not basically let me take a moment and think it through. Am I doing it right? Or should I do it the other way around? And this can also be a set of understanding. And believe me, that's why data scientists are not a kind of 2-minute noodles. They take their time. And it's a time-consuming process because you need to think it through. You need to understand the business problem first or what the business need. If you can't, then it's really a big problem because then you can't think about how to utilize that data or what data you need, frankly speaking. So understanding business problem in the relevance of the data at hand is the name of game. I hope I have clear good amount of doubts in your thought process. Now we are basically getting ready to work as a data scientist, and we'll basically work on these data frames. There are a couple of examples in our next session. Before that, I would like to hear from you. What do you think about data cleaning in your words? Okay, I'll share the recording even publicly as well, so that you can go through the recording. I'll share the even videos which I just shown to you, so that we can understand or we'll have enough ammunition to start building, start thinking of how I should address the solution. How should I start building the solution as a data scientist? Does that make sense?
Yes.
Okay, so let's meet day after tomorrow. Okay, and then think it through how we are going to basically build these solutions better day by day. Okay, chalo. Thanks a lot for your time. Have a good night. Bye bye.